with the annual survey, which I, since last year, do together with IPC. Right. IPC is quite some help in that respect. And we are now having more than 20% of European production being collected 4 weeks after the end of the calendar year. And we send out 80 pages report with all the predictions for the last year and the time to come based on those numbers from 225 companies in Europe.
Wow.
And that is
that's a fair sample. That really is.
It's a fair sample. But as you mentioned, we are now facing so many other difficulties, and we're not just collecting revenues and headcount. Very often we look into the P&L and the balance sheets, and we try to analyze more data. And as you mentioned, allocation, to us it is very important to have a look at inventories.
Yeah.
We are checking inventories, if possible, when they're reported in detail, which means work in process, finished goods, and raw materials. Then we analyze that in specific. And we all still remember the last allocation problem of MLCCs in 2018, 2019. That time we thought, we see a big jump from 18 to 20% of annual revenues in inventories to 22, 24%. But now what we have seen over the last 12 months in regards to the semiconductor allocation problem is something totally different. Many companies are now at levels of 38 to 40% of an annual survey in inventory.
Right.
And that means a lot of capital binding.
There's an awful lot tied up.
And we as well see that cash is getting quite a problem, and we just reported it this year with the annual survey. In the past we always had a certain distribution, but it was a normal distribution. It had a widespread, but it was one distribution.
Right.
Now, after 2021's analysis results, we all of a sudden see a double distribution. We see that about 30% of companies have performed very well in 2021, having an increase of more than 30% compared to 2020, and having made up for the loss in 2020 compared to 2019 as well. So they're really doing good.
Yeah, these bigger companies, I mean, are the larger companies faring better than smaller companies?
Yes, well, just to pick my brain, a couple of companies, we've just seen the first quarter result of Incap a couple of weeks ago, with 41% in revenue increase. It's incredible what is happening. It's definitely not normal. Because we have 40% of companies which in 2021 were not able to recover to the 2019 revenues.
Right.
As you say, it's difficult for us to collect all the data. It's not even good enough to just collect data. We have realized that we need to talk with the people much more often. We need to visit the companies. We always want to see production. We want to get a feeling for how much loaded they are, and we see huge differences. We see big companies who ask us, can't you find us some extra capacity because we don't know how to manufacture it all. And on the other hand, we see smaller companies who are just working one shift, who some of them even are on short labor, or they clearly tell me we've got nothing to do.
Well, here's the thing. I mean, are the Tier 1 and Tier 2 companies working on different margins from the Tier 3s and Tier 4s?
Yes. See, the point is, if you, and again, you need to carefully watch, if I talk about averages, interestingly enough, the margins of the Tier 1s are lower than those of the Tier 2s, even so Tier 2s are working in much smaller lot sizes. But the Tier 2 companies have to calculate their prices a little bit different. They have to have a higher margin, because their overhead costs are higher.
They have all these changeovers, and changeovers cost money.
Yes, exactly. So, but again, it's just the average. If we look to the sides, we are seeing a huge gap opening up, which is, to me, is scary. You might remember 3 years ago on Productronica, I made the prediction that in 10 years from now, 30% of all EMS companies in Europe would be gone. And today, I repeat it again. Yes, I still believe that is the case. And if I say they will be gone, it doesn't mean that they all go insolvent.
Merger and acquisition.
But there is going to be a lot of mergers and acquisitions. We've seen it already last year. We had, I think, nearly 50 mergers and acquisitions last year, just in Europe.
That's true, but the thing is that what's happening now with all the supply chain shocks and the inflation that's coming in, the money supply is starting to tighten up, and there's not going to be as much money around for M&A going forward.
Yes, well, what we have seen is prices are going up for acquisitions, on the one hand. On the other hand, we still see that some entrepreneurs have a totally different view of the value of the company. But that is nothing unusual. It's always the case that an entrepreneur thinks his company is much more valuable than it is in actual fact. And as we are now working in the M&A field as well, because we are asked, can't you help us? And unfortunately, in the majority, is people asking us, can't you find us a company which we can buy? We only have, at the moment, 3 companies on the shelf for sale, and those are not necessarily the good runners to sell, but we have 15 companies who are looking to buy another EMS company, and we are not trying to make a deal under all circumstances. To us, it is very important as we understand the business, and as we know the companies, we know where they are working in, we will never recommend just, hey, buy this company.
You want to find them a good home.
We want to find the right deal. It needs to make sense to merge 2 companies together. Because at the end of the day, we have the responsibility for the employees and for the industry.
Dieter, it's a fascinating subject. We could talk about this for hours, I know. But you're coming back to join us in a few minutes' time for the first panel discussion on tech decoupling, and we'll look forward to catching up with you there and discussing some more of these details. But for now, thank you very much for joining us.
Okay, thank you very much.
So coming up after the break, we're going to be joining my next guest today, who is Brian Craig from Indium Corporation.
Impressed.
How you doing?
But I'm sure that's not.
I introduced Robert, because Robert from Solid Chemistry is one of the acquisitions that we make. Can we make this a 3-way?
You could maybe do. Bring that chair in. Oh, no, we're too late. We're back on air. I'm sorry. Okay, so we're back with Brian Craig from Indium Corporation, and thank you for coming in.
You're very welcome. Good to see you.
Yeah, and my first question to you is, what are 2.5D materials? You mentioned 2.5D materials in the recent...
when did I do that?
When did you do that? I think it was in the recent press release.
2.5D materials. Well, Trevor, you've caught me out because
yeah.
I don't know what
they
that means.
are. Okay.
When did I do that?
We'll come back. It must have come from your head office, I'm sure. But there you go. Anyway, let's move on, because the other thing I wanted to talk to you about was nanomaterials. They're becoming much more prevalent in the market. What are the opportunities that are opening up for nanomaterials?
Okay, can we stop for a second?
Yeah.
Because you've asked me 2 questions that I know nothing about. I don't know where these came from.
Okay. Well, we'll keep going because the next one was something about the research work you've been doing with Catec Group.
Oh, okay, that is.
You know that one,
yes,
yeah?
I can help you with that. Okay, so
The beauties of live television. Okay.
So one of the wonderful things that we've been able to do is Indian sort of looks for solutions to problems.
Right.
And one of the great things you can do is if you can find somebody, a customer, who's willing to help you with finding a solution to a problem, you've really got something you can work with.
Yep.
And the challenge that Catec was having was that they make automotive modules,
Yep.
so complex automotive modules. And if you have a complex automotive module, typically you want a vacuum oven to make sure that you reduce all the voiding on the components, particularly flat bottom components. When you have a component, a module that's not got such complexity, but you have one or two products that may have voiding,
Yeah.
the challenge is you don't really want to put that through or invest in a full-scale vacuum soldering system.
Yep.
So what we did with them is we worked with them to develop a process and materials using the flux-coated preform technique that we have,
Okay.
LV2K it's called. And we were able to optimize with them our product and their process to eliminate the voiding, almost eliminate the voiding on those special components.
Okay.
So what they've done is they've put together this program where they're sharing what we did with the data, both with Catec and with Indium. And there's a presentation that was here this morning on that, to really share that with the industry, because investing in a vacuum oven, that's a big commitment.
Significant.
So if we can, no offense to the vacuum oven people, there
Right.
are reasons why they have those too.
Yeah.
But if we can help other people solve those solutions using a technique with flux-coated preforms, I think we've got something that's useful to the industry as a whole.
Yes.
And if we can do that, the whole industry benefits.
Right.
which I
So
think is
you're basically you're coating the balls with that flux avoidance.
Well, it's usually with a
flux chemistry that avoids.
Yes,
voice.
yeah. So you actually, when it comes to soldering with a flux preform, you don't need very much flux.
Yeah.
It just has to do its job to remove the oxides and activate things and to
Yeah.
make the solder work.
Yeah.
And so making sure that you've got just enough flux, the right type of chemistry to make sure you're not increasing any voiding and you're getting great wetting between the surfaces that you're bonding, I think is something that's really useful.
Right.
And the whole industry can benefit from this, at least in the power module world,
Yeah.
which
yeah,
is one of our
yeah.
focus areas.
Yeah. No, that's very, very, very helpful. So you can afford to do that with, presumably, with companies that are doing relatively short runs on things.
Special products, short runs, and unusual designs.
Yeah. Yeah. Okay. So let's turn our attention very quickly to the automotive industry. You do a lot of work in the automotive industry. What are the current trends coming out?
Power. So we've got this, no doubt many of your audience, and you've heard of this Rely On program that we have, which really focuses at the whole e-mobility market. So when we talk about automotive nowadays, it's not just the car, it's the infrastructure that goes around making the electrically powered car move.
Right.
And so charging stations and booster stations and transformers and things like that, converters. And so the amount of power that's needed as the powertrain of the vehicle increases, so hybrid electric, 12 volt, 48 volt, full electric vehicles, you need to be able to switch things on and off very reliably, very quickly.
Yes.
And that means that the power modules are becoming, the demand on power modules is increasing all the time. So high reliability means things like, I talked about it already, the low voiding, high reliability solder joints, no cracking, nothing going on, and it's going to go through a large number of cycles as these things are switched on and off for years.
Right.
No maintenance, no issues, nothing.
Right.
And so the trend really in the automotive industry is the infrastructure part of supporting that, getting the power to recharge batteries, and also the reliability of making sure they work all the time, every time.
Every time, yeah. It's an incredibly important area, and it's only going to get worse. Do you think they're going to extend the boundaries for testing? I mean, it's currently minus 40 plus 160, isn't it?
Well, minus 40 plus 150, 165 is the next one. So yes, and the number of cycles within that. So there's talk about that, and typically when we do our reliability testing and we work with our customers who do the same, we're trying to make sure that we're exceeding the demands of that testing all the time, as you would expect.
Yeah.
So nothing, no rocket science there, but we want to ensure that the solder joints that we're helping people produce are able to handle not only what's needed today, starting with 125, then 150, 165 is next. Those applications are demanding, and we want to make sure that we're well ready and well ahead of the curve when it comes to helping people develop their processes.
Yeah, great. Well, it's a fascinating area, and I want to thank you for coming in and telling us about some of the projects you've been working on. Sorry about the earlier questions.
Well, they were good ones. I'll have to go and figure out what that was.
I'll give you some reading material later.
Some good education on how to perform in live TV.
Yeah, absolutely. So anyway, thank you very much. And of course, coming up after the break, we're going to be speaking to our third guest this afternoon, which is Chintan Sunturai from CalcuQuote. Yeah.
Sorry, I don't know where you got those from.
Electronics are part of our world, expanding by application to open up new opportunities for automotive, healthcare, and many other industries. But today's manufacturing techniques are not sustainable. They are energy hungry and inefficient, expensive, and have limited flexibility. The world is asking us to do better. Introducing Pulse Forge tools, a new approach to thermal processes like soldering and curing. Design with more flexibility, manufacture with fewer process steps, reduce energy use, and decarbonize the supply chain. Expand your creativity to new levels. Designers are asking for more. They need to reduce form factors, reduce weight to work on wearables and stretchables, opening new market opportunities for consumers across the world, asking us to do better. If you think sustainability and freedom of design are not possible in electronics manufacturing, think again. Think PulseForge.
You look at me. Yeah. And welcome back. Okay, I'm joined now by Chintan Sunturai from CalcuQuote. Nice to see you again, Chintan.
Good to see you too.
Yeah. Now, you've come out with a really exciting new platform. At the moment, one of the big issues in the industry is the supply chain shocks. And what's happened is a lot of contract manufacturers and OEMs even have purchased a lot of excess inventory and they're sitting there on a lot of money that's tied up in stock and it's starting to hurt their bottom line. But you've come up with a solution for that. So take it away and tell us a little bit about it.
Yes, so Stock CQ basically originated from this idea that one person's trash is another person's treasure. So we came up with the idea because we had EMS companies coming to us saying, I really am desperate to find these parts. They're not available in the primary sources that I usually go to. I'm having to go to aftermarket situations. And it turns out, I find out later that it was my neighbor that had the parts. And so we said, well, why don't we help connect you guys? So we did some study, we looked at the data we had, and it turns out that in about 1/3 cases, 30% of cases, we were finding that there was an overlap between company A having excess material that company B was short on. Right. So we said, well, let's just create a network where you guys can directly talk to each other without having a third party involved, and that's what we did. So, and Stock CQ, named because it's a virtual stock room that anybody can access, and it's a closed community. Mm-hmm. It's exclusive to EMS and OEM companies, so it's people that have parts and use parts. And what it allows them to do is upload all of their excess materials and then search it to see who else has the parts that I need. And when they find a part that they need, they click a button and it introduces the seller and the buyer together and they work it out from there.
Right, right. And so is this something that's open to CalcuQuote customers or is it open to anybody?
It's open to anybody. Anybody that's an OEM and EMS company, it's open to.
Okay. And what sort of information do you ask for? I mean, how many parts have you got? What value are they? And what about the condition and aging of them?
Yeah, so there's basically we held roundtables, so we had more than 100 EMS company executives attend these virtual roundtables we did to explore these types of topics, because we said if you guys are all going to work together, how are we going to do this in a way that's fair and it's going to support all of your businesses? And the feedback we got was they said, we have the information that you're asking for about date codes and traceability and all of that stuff. It's just a matter of cataloging it. So what they mutually agreed on across the 100 or so companies that participate in these was to say, when you want the part, tell me and I will provide all the details about the part, but I don't have that in a structured data set to be able to provide, and it doesn't make sense to waste time when we're already busy looking for all these parts.
Right.
So that was the solution, was to say, let's just make sure that we have that information available so we can provide it before you commit to buying them, but we're talking directly between the seller and the buyer. We don't need a third party to intervene and translate that communication for us and slow the process down.
Right, right. So it's really essentially just a free service that you're providing, because you're not handling any money. There's no transaction involved.
Yeah.
You're just introducing the buyers to the seller. And
yes, today it's a completely free service. Anybody that is an OEM or EMS company can use it. We do eventually plan to figure out a way to basically make it not a loss leader for us, right? Like, we don't want to lose money on it. And we've had those open conversations to come up with a fair way. We don't want to become a broker. We don't want to handle parts. We don't want to do any of that stuff. Our primary business is still quoting and purchasing software that helps EMS companies be successful. Yeah. But this is a way for us to solve one of the biggest problems that our customers are facing.
Yeah, it's huge. It's absolutely huge, and it's a critical problem in the industry right now. So congratulations on coming up with it, and I wish you absolutely every success with it, Chintan.
Thank you very much.
So thank you for coming in and telling us about it, and we'll look forward to watching how it develops over the coming weeks and months ahead. So that's it for the first part of Live at SMTconnect. Coming up shortly is going to be the first of our panel discussions, the effects of tech decoupling on the supply chain. 1, 2, 1, 2. 1, 2, 1, 2. 1, 2, 1, 2. 1, 2. 1, 2. Okay. All right, we're...
1, 2, 3.
Sorry? I've got 1. I got 2.
One, two, one. There we go.
1, 2, 3. 1, 2, 3.
Good, thank you.
Okay.
Last week, that conference. It's an expo and a conference, 548 people. Wow. Yeah, pretty good. It's, yeah. Yeah, there's one guy from Brussels didn't particularly like it. He put in Brussels to Malmo on his flight planner, and he flew to Stockholm, then he flew to Gothenburg, then he flew to Malmo. He was traveling the whole factory.
Are we ready?
No. Take the train from Copenhagen, which is in Denmark, across the sea. Yeah. And then I checked it. You only go to a lot of the flight paths.
And welcome to the first of our panel discussions here, the effects of tech decoupling on the supply chain. The recent war in Ukraine is the latest driver in a fast-moving drive towards tech decoupling with countries such as China and Russia, being cut off from access to Western technology and materials. How do companies operating globally navigate these troubled waters, and where access to markets can be restricted by governments and very often at short notice? I'm joined today by 4 panelists. To my extreme left we have Keith Bryant from Keith Bryant Consultancy. To his right we have Tom Forsyth from Kaizen Corporation. And to my immediate left we have Dieter Weiss from Informa. So welcome, gentlemen. Thank you for joining me today. My first question is, early in the pandemic, it appeared that technologies were diverging between autocratic states microcontrolling their citizens' lives and those in the West who valued their freedoms and didn't want to share everything with the state. Is this really happening? Tom?
Well, you know, the early days of the pandemic were tough, right? To deal with these issues. People were trying to figure out what was true, what were personal issues, and then what was demand going to be. There was a lot of reaction to some companies really throttled back on purchasing. that information flowed to their suppliers, who got scared and stopped their supply lines. As we all know, it's a lot easier to turn off supply lines than it is to turn on supply lines. Perhaps we knew this before, but we've certainly been, retaught that lesson. That's what happened to a lot of the automotive guys. They were all buying all their chips from Taiwan. They canceled their orders. The guys in Taiwan said, okay. They came back 6 weeks later and said, oh, well, you gave up your spot in line. It'll be 6 months or 8 months or 18 months. So there were a lot of, it's kind of like the stock market, right? Like today, the U.S. stock market is in free fall.
Yeah.
And the people that lose are the ones that give up today. Because, so those reactions are what cause a lot of those troubles in the beginning. And now we're just, our supply chains are so integrated and so complicated.
Well,
It's a deep hole to dig out of, I think.
Yeah, there's been an awful lot going on, and it's a combination of effects. But you mentioned there the supply of components to companies from Taiwan. I mean, there's definitely been some examples of companies, Chinese component suppliers, favoring their Chinese customers rather than letting these components come to their other customers in the West. Now, it's probably a case of the Chinese customers are larger users, they use the volume materials. But have you come across any examples of that, Keith?
Yes, several. I mean, one of the things that you're seeing, and it's human nature. You're going to take care of the people closest to you in terms of customers, and yeah, generally they're also the biggest customers. They're paying in the same currency. You don't have all the shipping times and all the hassles and everything else. It makes life so much easier. So yeah, when there is a constriction, it's the people that are a long way away that suffer, and it's really regardless of the prices that they're paying. It's a lot easier to deal with the people that are that close to you than it's harder to deal with all the others in different time zones. And you're always, everybody became worried about things flying because nothing flew. Ground transport became a nightmare. Everything in the sea got stuck. And if you can just put it in a truck and send it to somebody, and a few hours later it's there, then life's easy. You're going to get paid. So you can't blame anybody for taking those options.
Yeah, Dieter, I think that's right. There's one of the big drivers as well, of course, has been the freight prices. The freight prices have gone through the roof. So it makes a lot of sense to have shorter supply chains.
When we look at the allocation problem in general, first of all, we have to see the last one, which was MLCCs, was totally different. The one on the semiconductors now, we have to realize that the value of the individual semiconductor is much higher. So the impact for the industry is or has been much severe. And when the automotive industry drove their build programs down, at the same time we had the lockdown situation, and we saw a rise in demand for communication equipment, for video conference and all of that, and those products in the majority are being manufactured in China. Yeah? So it is for sure that there was a drain from the Taiwanese foundries to China, and not necessarily to Europe. Yeah? And when the automotive industry finally decided, we want to build some more cars again, the capacity was gone. Yeah? Tough luck. Yeah? And then they started complaining and blamed everybody. But in actual fact, it was themselves who was to blame.
Except for Toyota. Interestingly, Toyota, what I read, okay, perhaps not true, but what I read was that after Fukushima, Toyota did the same thing that all the car companies did this time, where they said, we don't know what's going to happen, stop orders. And they got out of line and they got in trouble starting back up after Fukushima. So when it happened, and the same problems, the same terrible challenges. Yeah. So this time around, they were the only guy that didn't get out of line. Which is why they kept selling cars. Yeah. Right. Okay.
Yeah, they basically kept their supply chains open and did everything that they could to keep everything running. And
They've made the
yeah.
same mistake before.
Yeah,
within recent memory.
Yeah, they learned from a very, as Tom says, that they learned from a very bad mistake. But I mean, multinational companies currently are using their facilities in China to buy components and then shipping them internally.
Yeah.
Yeah, and they're doing that just to get over the fact that the Taiwanese and a lot of the Asian people are supplying to whoever's nearest. And yeah.
Things are, the stories of things getting stuck in containers and ports. Everybody at this show has one of those stories. Okay, so that's not an unreasonable preference to my mind, as unfortunate as it is.
So Tom, what are the dangers then of tech decoupling?
Well, I think there's a very clear lesson from these goings on, is that it's not a crazy idea that sole sourcing is bad, right? I mean, everybody, governments don't like it, companies don't like it, but fundamentally, we have largely gotten in that boat for many things, perhaps not intentionally, but yet we're in that boat. I think there's going to be a very clear, strong, strategic decision made in 1,000 companies to say, like Toyota did, okay, I did a logical thing, I got burned. Well, when the next time comes around, I'm not going to get burned this time. I think you're going to see vast chunks of the industry make small decisions to make sure they have supply in lots of places.
Right.
Which means that's opportunity for people to make things in different places that maybe 30 or 40 years ago was commonplace, but today is not. I think you're going to see that change start to grow in lots of different places, and some of them unexpected, whether that's in the States or in Western Europe, where you think, it's too expensive to do that. I think you're going to see some of that stuff grow there, because I don't think people are going to want to live through this again in 10 years.
No, I don't think so. And I think as if each supply chain shock comes in, it's going to drive people more towards doing these second and third sourcing and more regionalization.
And not 5%. I think you're going to see meaningful shifts of quantity to make sure that, because remember, every manufacturer needs somebody to base load their business, right? That's how the lights come on. So, you give me 5% of your business, well, I'm not going to be there for you when things get scary. You give me 30 or 40% of your business, well, now you're important to me.
Right.
I believe that we're going to see lots and lots of that in a million different ways across the industry. Now, it'll take time for that all to happen, but I believe that is a path that is in front of us with little doubt. What do you think?
And on top of that, we see the infrastructure, which is getting more expensive. We saw container prices rising by 600% last year. All of that had an impact, but even worse is that the supply chains were interrupted. People in the logistical department, and I have to say, my daughter is working in logistics for a big American company in Frankfurt, and she said we couldn't rely anymore on our Chinese suppliers because we didn't know when we would get the product. So they finally pulled out last year 2 products from China, and they brought them back. It's insourcing. It's not being manufactured by an EMS anymore. The companies manufacture it themselves in the factory. And at the end of the day, the engineers were smart enough to develop the processes in a way that they said it's the same cost as it had been when we sourced it in China.
Yeah.
So it is possible.
It is possible. But the freight prices, that brings me on to my next question, which I'll start with Keith, and that is, the current situation in Shanghai. I mean, is the Chinese policy for zero COVID, is that going to filter through into another supply chain shock for the electronics industry? Because the number of factories that are closed out there is ridiculous.
Yeah. I mean, the factories are closed, and I don't know if you guys have seen it, but there was a lovely picture of the harbor, which is I think the second largest in China and about the 4th largest container port in the world. And there's something like 380 container ships just moored off it that can't come in, can't go anywhere. And obviously, if they're not unloading, they're not loading up to take what's there.
Right.
Apparently, they're having to buy extra space to put the containers that they can get in there to move them on. And yeah, then you've got poor guys in factories who are living in the factories now because they can't go home, they can't go anywhere because of the lockdown, and the only way they can keep production going is to basically live in the place that they're working, and then they can produce stuff. And then it's a nightmare then to get it out of the quarantine area, to get it to the port, to get it shipped. And
one of the unsung stories, Keith,
yeah,
and this has been happening throughout COVID in all parts of the world. In that, they'd say, "Oh, well, your factory's making a strategic something, so you're open. It's no problem." Yeah. But the lorry driver can't come get the product or bring you more raw materials.
Right.
So you're an island until you run out of raw materials because they can't, and they may be at the port, maybe they're near, but they can't get delivered because these rules are very complicated. I think all the governments of the world, in their own way, and governments aren't great at stuff like this. I don't care where they are. They've said, okay, well, yeah, we want you're strategic, so you're open. Oh, you need the lorry drivers. Well, a week or two later, go, okay, we'll figure something out about the lorry driver. Well, then we need some other piece of it. And what they're doing is they're making these thin little narrow supply chains that, back to your daughter's point, are by nature unreliable. And that we've gone from these hyper-reliable, hyper-predictable systems to something that's maybe the opposite.
Oh, completely the opposite.
And we've grown our companies over the last 30 years relying on those efficiencies, and now we're back to dealing old school with hand signals and waving, right. and it's been challenging for everybody involved, I think.
I think the argument for regionalization is now quite compelling. It's compelling
Absolutely.
From all of the geopolitical events and the supply chain issues, and also even sustainability. Reducing the carbon footprint. Why should we be sending things across the other side of the world? The only problem is that we've got to make sure that every part of the supply chain is in each region. There's no point just making chip fabs. You've got to have PCB manufacturers. You've got to have OSATs. You've got to have everything else.
And that's
to support
why this is many years in the making.
Yeah. And you have to realize today the European PCB production is at such a low level. You couldn't even pull back half of the demand in Europe back from Far East to Europe because there is no capacity left.
Yeah. The U.S. is the same. I'm not sure what the percentage is, but it's very significant.
Well, 85% of your boards are made in China.
Yeah.
I mean, literally.
Yeah.
Global production.
So we still have a lot of homework to do, definitely. And by just discussing at the moment what the European Union is doing, discussing that we need to have more foundries, more semiconductor manufacturing in Europe is not good enough. Yeah? We need to look at the full supply chain, and even if we cannot guarantee full supply and full independency, but the amount of dependency needs to rise. Mm-hmm. We need to have more local manufacturing, not just on the PCBA, but as well on the PCB and on several other components which today, and I don't have the overview, but I think a lot of those very tiny chips like resistors and so on are in the majority manufactured in Far East at the moment.
It's a brave new world. I think lots of opportunity, lots of challenges to get there, long-term play, right. And of course we live in a world where policies are anything but long-term generally. So
well, generally, when governments
off.
make policies, the problem is they're sweeping.
Yeah.
They're huge. But one of the other issues against the regionalization argument at the moment is the labour problems. I mean, the labour problems are across the world, but are they still going to be the choke point going forward?
Yeah, I mean, labour is a big one, but I'm going to break the rules and ask Trevor a question.
Yeah.
Do you remember in the UK when we used to mine tin?
Yes.
Because it's fine talking about PCBAs and PCBs and everything else, But we need to be able to have control over the base materials, or we can't make anything.
That's true.
And we have to get back to that level if we're going to do it properly.
And in fact, it's not just the mining. One of the odd things about some of the rare earths, and there's been lots of press about how they're mostly sourced in certain parts of the world, but the U.S. in fact has loads of rare earths, but we've chosen to not be the processor of those. So we dig them out of the ground and put them on a boat, presumably, that then goes off to somewhere where they get processed. Chances are worth more money at the end of that, and then they make their way back.
And you also chose to pull out of a country that is the second biggest copper mine in the world.
There's that, right? So it's partially digging it out of the ground in some cases. It's partially the processing. And your point about the PWBs, the boards themselves, those are industries that in the U.S. and Western Europe, the regulators haven't liked those businesses. So they've been, there are a few left, but the capacity is not there for the volume. That's for sure.
And not only that, if you look at the engineering people who used to work in the PWB business, most of them are retired now. So we see a brain drain as well.
Yep.
I'd say in 10, 15 years from now, if one day somebody came to the idea, let's start manufacturing PWBs again, you first have to ask, where do we take the experts from? Because they are all gone. Yeah. So that's another problem. But within Europe, we still see a huge difference in the employment levels. There are many companies in the east, for example, Czechia, Slovakia, Hungary, who have full employment. They have nearly less than 3% unemployed people, which is full employment, more or less. On the other hand, we have countries like Romania, Serbia, Portugal, Spain as well, where we have high unemployment rates and where it would be beneficial to set something up to help the people go to work. Right. And going further, probably not at the moment the best idea, Moldova, even though it's a small country, but they have a lot of labor potential, and Ukraine as well. Yeah? Remember how many people used to work in the electronics industry in Ukraine, from Ukraine in Eastern Germany, Eastern Europe, like for example in Hungary or in Slovakia, or I know the world's biggest EMS in the Czech Republic, he used to employ a lot of people from Ukraine.
Yeah, it's certainly reverberating around. And I mean, talking about Ukraine, of course, a lot of the raw materials that we use in semiconductor manufacturing come from Ukraine. But as we spoke about earlier, when Russia invaded Crimea back in 2014, the semiconductor industry at least had the foresight to start doing second and third sourcing at that point for the the high purity neon gas, for example.
I think, as far as I know, they put half a year's supply on storage to make sure that they were able to continue manufacturing.
Right.
But your point about that is that's not just true for certain things. Because supplies are short, people, whether they're buying them in China and shipping them internally or just anywhere, inventories, whereas a year or two ago, before COVID, inventories were low, just in time, just in the nick of time.
Yeah.
Inventories are very different from that today. People can buy it, they're buying it, they're getting it inside, so they can make that production schedule when they get everything together. So I think end user inventories, I think, are at high levels.
But it's also causing problems as well, Tom. There's a lot of small manufacturers that are really hurting because they're stuck with inventory that they can't use,
right.
And they can't dispose of easily. But anyway, let's move on to my next question. I want to get through a couple. There's many financial pundits out there that are predicting a global recession, with demand intent running at 272% higher than last year for new products introduction in electronics. Do you think the electronics industry is likely to ride out the storm better than most?
Well, over the last 20 or 30 years, the answer to that question has been yes. That during the during the Y2K and 9/11 phase. The software guys kind of took it on the chin, but the industry survived. During the meltdowns in 2008, where kind of in big financial challenges, the industry really rolled through without
Too much
disaster. So I think the odds are in our favor, but these are not fine-tuned instruments that the governments have to use to try to change the elements of our economies. So it's always hard to predict, what sort of turns out on the other end, and throw a little trade war and tariffs and a war, a land war in Eastern Europe on there. I think it's very difficult to really call that very well moving forward. There's a lot of dynamics that are very non-traditional right now.
Keith, I mean, you've got a lot of customers. You work with a lot of customers that are bringing in new products and introducing them into manufacture. Are you seeing a big, insatiable demand there?
Yeah, I mean, if I was to sum it up, it's everybody's trying to make it business as usual. As I forget who it was, but one of these guys to my right said, we had COVID, and suddenly everybody wanted to buy electronics. And that's the nature of electronics. It's such a broad basket of things, and it sits in everywhere. We were selling more laptops because people were working at home. We were selling more screens because people were working from home. We were selling more internet connections because people were working from home. Unfortunately, we were also selling a lot more medical stuff because that was needed at the time. And we'll, as Tom says, we'll go through these cycles. But I think, if somebody, it would be as bad as trying to shut the taps off because COVID appeared. I think if people were trying to reduce new product introductions, they were trying to not put out upgrades and everything else, then first of all, it's a crazy thing to do because your competitors are going to carry on doing it. So I think the market wants it, people need it, and it's going to carry on going through. Okay. And if there's a recession, less people are going to be able to buy new stuff. People will upgrade. There's a lot of, I'm seeing in consumer electronics now quite a few clients who are refurbishing everything and reselling it because it's better for the environment, it's better for the world, and it's a lower cost to the end user. And who cares if somebody used your iPad before? It's completely wiped, it's cleaned, it's checked, and it's literally as good as new. So I think that we're going to carry on.
Okay. Well, here's a question for you, Dieter. Is the European ban on Russian coal and oil likely to impact the EMS companies in Europe?
Well, first of all, we have to realize, is this ban coming with immediate effect, or is this something that's going to happen over time? At the moment, we have a lot of countries complaining, like Hungary, like the Czech Republic, like Slovakia, who say it shouldn't start immediately. And with the German economy as well, coal is probably not a big problem. We can take that off fast enough. Oil is a little more a problem, but there are alternatives coming from the Arabian countries. I think gas is the biggest problem because we still today need a lot of gas to generate power, current. And if that is cut off immediately, the government will have to make a decision whom to take off the line. You remember that, I think that was last year during the Olympic in China, when all of a sudden the Chinese government, with the argument that they wanted cleaner air, shut down their coal incineration plants, power plants, and then told different industries, you cannot manufacture today. That would be a similar situation over here in Europe if the governments decide to cut off as of tomorrow.
I think they're going to phase it out towards the end of the year. That's my understanding.
Definitely we need to find alternatives, and we cannot find all these alternatives from one day to the other. And we are talking now about different ways, even in Germany, to get to gas again. And fracking is one of the words which has been very negatively discussed in the past when a lot of fracking was done in the United States. But if the pain is high enough, you start rethinking. We are discussing all of a sudden now again as well to leave our atomic power plants running a little longer.
Right. Well, it's amazing how things have turned around so quickly from COP26 last year because of all the problems that we're suffering now. I'm going to move on to my last question, and that is simply, is digital transformation in manufacturing our best hope of putting in place systems to help us cope with these supply chain shocks in the future? In other words, if we've got digital control of a lot of this stuff, is it going to be easier? You know, the factories are more digitally agile?
Well, I think what we've learned over the last 20 years probably is that our digital data sets and our control technology has improved vastly. You know, when you look at the last few recessions around the world, they weren't a slope. They all were very sharp drops, and I think that was a tribute to the information technology. It's that demand was drying up, let's adjust. I believe those tools are going to be valuable as people try to negotiate this. But the challenge continues to be visibility.
Yeah.
You know, when you're in a smoke-filled room, it's pretty hard to see where you should hang the picture on the wall, and we're really in smoke-filled rooms right now.
Yeah.
I mean, that's the challenge. Our industry, as Keith said, has been very resilient. You know, thankfully. Okay, but yet the supply chains are still very opaque. You know, new innovations are delayed because you know, some new EV guy comes out with a great product and goes to Taiwan to get chips made. When's his place in line? Okay, it's not this year. So innovations will be compromised to some degree. You know, there's a major tumult that's still before us that I'm not even sure. Maybe it's peaking, but it certainly doesn't seem to be getting much better yet.
Well, just when one peaks, another one, or when one starts to subside,
right.
another
The
one
next mountain
comes up.
shows itself,
Yeah.
right? So.
Anyway, gentlemen, I think we're going to have to leave it there. It's one of these topics that is multifaceted, and we could talk about for hours, I'm sure. But I want to thank you all for coming in and stepping in so quickly. And thank you to our audience out there that are watching, because we've been running a little bit late this week, where our next panel will be coming up in about 15 minutes' time. But for now, I want to thank Keith Bryant from Keith Bryant Consultancy, Tom Forsyth from Kaizen Corporation, and Dieter Weiss from Informa for joining me today. And thank you for watching.
Thank you.
Thank you.
Thank you.
Electronics are part of our world, expanding by application to open up new opportunities for automotive, healthcare, and many other industries. But today's manufacturing techniques are not sustainable. They are energy hungry and inefficient, expensive, and have limited flexibility. The world is asking us to do better. Introducing Pulse Forge tools, a new approach to thermal processes like soldering and curing. Design with more flexibility, manufacture with fewer process steps, reduce energy use, and decarbonize the supply chain. Expand your creativity to new levels. Designers are asking for more. They need to reduce form factors, reduce weight to work on wearables and stretchables, opening new market opportunities for consumers across the world, asking us to do better. If you think sustainability and freedom of design are not possible in electronics manufacturing, think again. Think Pulse Forge.
At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.
Ko Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, we revolutionize the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Ko Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges.
Topics are here. Hello and welcome to the second of our panel discussions today, the digital transformation in manufacturing. This is the first of two debates looking at the current status of companies transitioning to smart factory concept. This panel will examine the digital transformation, which comprises, of course, machine learning and artificial intelligence, analytics, conditioning monitoring systems, predictive maintenance, digital twins, and augmented and virtual reality. Joining me today, I have remotely, we have Michael Ford from Aegis Corporation. Hello, Michael.
Hello.
Nice to see you.
Hi.
You're calling in from the US today, are you?
I am. I'm in Wisconsin.
Wisconsin. Oh, lucky you. Okay. Then to our extreme left, we have Keith Bryant, and then to my left here, we have Harold Eppinger from Koyoung. So we'll get started, and I'll start off with you, actually, Michael. My first question is, does the Global Smart Industry Readiness Index offer a potential level playing field for companies to assess their current position on their digital transformation journey and offer a roadmap for which areas they need to improve?
I had a look at this. Yeah. It's a very interesting document, actually, and it really addresses one of the key issues that there are when factories or operations are trying to go through digital transformation. Because, it's like, would you go out and buy a car if you'd never taken a driving lesson? Right. You're not going to get the best out of it. So understanding the readiness of your operation to be able to take maximum advantage of the digital transformation tools that you'd like to put in place is very important. Yeah. And, I do see in the market that those who are successful are those who have achieved a high level of this readiness.
Right. So, Michael, just for those of us that are not familiar with this particular project, or the Global Smart Industry Readiness Index, you've had a quick read through it. Can you explain exactly, what it is and the premise behind it?
It's really looking at where we are today in terms of the kinds of technologies, tools we have, and it creates a kind of maturity profile. So there are various different aspects that are being looked at, being measured and evaluated, and then going through and having a look at what is the current state of the factory so that you can go in and have a think about how you compare to that level, and you end up with a score. They call it a SIRI maturity score. So it's very interesting to actually go through and compare your operation with what is described in the document.
So, I mean, Keith, do you think in general that there's value in having a system that measures you and your capability for digital readiness so that OEMs can maybe in the future say, well, we are putting a job out to tender, but you need to have a global readiness figure of or capability of more than 80, for example?
Yeah, I mean, I'd come at it from a slightly different angle, Trevor, and I'd say if it shows people what they have to do to move forward, then it's a great benefit because that's what people need to be doing. There are some companies that haven't started. There are some companies that are moving along. There are unfortunately some companies who are just paying lip service to it. And I think, if you have something that tells you basically where you are, the real important thing is it tells you where you need to go. And, nobody's going to be scoring 10 out of 10 within our electronics industry today.
Right.
But, if they're scoring enough and they think, this is where we need to go to get to the next level and the next level and the next level, then, it becomes a framework for growth.
Yeah, I mean, Harold, I think it's definitely potentially a good system for galvanizing people to make them start to pay attention to their digital transformation, because as Keith says, there's a number of companies haven't even started yet. So if they're listed on a league table, if you like, and they seem to be fairly low on that spectrum, then it's going to galvanize them to want to get it more involved and push their automation digital journey.
I think the most important aspect, and I agree to Keith, it's in the beginning as an advisory index to know what to do and where to go for. I see the people starting very often jumping into the digitalization and jumping in and not having done and executed the basics.
Right.
So they are catched later on a very critical moment that the whole picture is collapsing. So I think the index might be a good part, but I believe the guideline to go for, this is the basics, this you have to go through, and then you can utilize this. We see this process, but we are very often to the huge amount of data we are collecting in the manufacturing process, we are able to collect,
right.
that it's not, nobody has learned to execute it, to realize it. Yeah.
Right. Okay. So I'll move on to my next question. I'll go back to Michael, and that is, should sustainability and security be considered as a key performance indicator?
These topics are obviously very important to a lot of customers, end users of products. So I'm seeing a lot more interest in this. Would it be a key performance indicator? It's tough to say, because normally KPIs are kind of measured around quality or performance and things that directly impact the, let's say, the cost and quality of the product, obviously. Whereas sustainability and security are not. However, you could think that, if there was a compromise in a product, such as a risk of a cybersecurity attack, that could compromise the product in terms of quality and performance. So kind of indirectly, there is a relationship. But I think, as we move forward, with people demanding more and more consideration of security and sustainability, the environment and those kinds of things, there will definitely be a measure. Whether it will be called a KPI, yeah, probably it will be. And will it be as important as other KPIs? Well, I certainly hope so.
You have any views on that?
Yeah, I pretty much agree with everything that Michael said. I mean, a lot of our stuff today is interconnected to everything. We have Bluetooth, we have Wi-Fi on just about everything, including a smart dog collar for our dogs so we can see where they are.
Yeah.
So, there's so much potential for hacking and damage and all the other things. So, yeah, I think, security needs to be taken in there. And, if the COVID thing has taught us something, it's, sustainability is becoming more and more important. So, yeah, I think, as Michael said, if they're not KPIs today, they should be soon.
Yeah. Okay. Question for you, Harold, and that is, because you're in the software business, of course, and are there any key differences in how software companies are applying deep learning and AI, and does the approach vary geographically?
I think it's right, it's everywhere, and you cannot oversee it anymore, that everybody has to use the AI, deep learning, machine learning. And we have seen there are some more and more intensive expertise in the different regions how to utilize it. That it will be applied worldwide, it's clear, but as you know, we have a R&D center in San Diego because artificial intelligence is much more common in the US, and we utilize this expertise there. But following with other regions where they have a specific know-how.
Right.
So it's absoluteness, and you see it, it's executed, it's part of our complete software package.
I mean, but you obviously run the German division of a company, and in the European Union they're bringing out guidelines on how to develop AI, which I'm not particularly sure that everybody else is going to follow. Are you hearing anything about this?
Not directly, because definitely we are not developing software in Europe.
Right.
That's clear. But when I talk to our experts, they clearly say they have very good capabilities in the different regions. So there are some experts, and I'm wondering if we should say that it's just starting to reconsider how to do it. This
Right.
might be quite a little bit late for this industry, and maybe for our industry to utilize it. But then something is wrong, because there is no label without AI or deep learning here on the show.
Well, yeah, that's just a marketing thing. But I mean, what I'm getting at is that the European Union put together a panel of experts to decide on things. And one of the more controversial ones is that at the end of every decision tree there must be a human making a decision, which seems to fly in the face of having AI, I guess.
Oh, it doesn't seem to, Trevor. It does. It is what it is, and we go back to the fact that the horse designed by a panel came out looking like a camel. It's a dangerous thing, and sometimes you're better, to leave the experts to do what they're good at and develop what they develop. Because if you start trying to have panels within government to control it, effectively all you'll do is you'll handicap the people that are working in that country because they just won't have the same abilities as the people that aren't shackled by the same rules.
And I would like to add a comment. I think our generation is a little bit more afraid of automatic decision processes compared to the next generation, over next generation, because that's part of the life. I think the acceptance is different. I think we are more afraid, and we all know that maybe a machine will decide much more clever.
And we can have an autonomous taxi without a driver. Why can't we have an AI chain without a person at the end of it making the ultimate decision?
It's very true. I'm just pointing it out, raising it because it is out there. Okay, let's move on. Michael, can we expect to see more sophisticated condition monitoring sensors in the future?
Could I just answer the previous question a little bit? Sorry. For the AIs, we have to think about the level of AI, because there are AIs making decisions all the time without anybody taking any notice whatsoever. It's the big kind of decisions in AI that are the things of concern in the European Union. What we are seeing in manufacturing, let's just base it in manufacturing, is we see a lot of niche players, machine vendors doing machine learning, things like that. Academia, there are many different projects which we are invited to participate in, where they now suddenly have access to a huge amount of data coming from the shop floor. They would like to use that to create some kinds of decisions for planning or maintenance or things like that. And it's amazing stuff that they're doing. But the problem is, what do you do when you've got to a conclusion with that AI software? How do you then kind of action that into an MES solution and therefore onto the shop floor? So what we're looking for is a kind of ability to rationalize those decisions, plan them, get them put into the minds of the people in manufacturing so that they can either accept, modify, or reject those major decisions that are made by those AIs. So you will have a kind of distributed AI technology arena where many different algorithms are working all over the place, doing different things, analyzing data in different way, and bringing those conclusions together at the point of use, which is in manufacturing, which is managed through MES. So I think from the MES perspective, this kind of European directive is not going to have a huge amount of issue, simply because they are relatively small decisions, less dangerous, I guess, and there will be this MES layer that is used to manage the execution of any actions that are taken as a result of AI decisions. So I hope that makes sense. Just to go on to the next question about sensors. There is another revolution going on, of course, because we see autonomous robots being able to touch and feel things. But there are a lot of new sensor technology being introduced, and this is great from the perspective of things like predictive maintenance, where instead of having to go and touch a motor to see whether it's running too hot or vibrating or doing something it shouldn't, we can now start to measure that, like the current patterns that it's using, or a record of the vibration and the heat in that motor, so that that information can flow through to, an AI, who would then look at that motor and think, I need to make a decision to replace that motor at the end of the current production so that I don't disturb anything, and then I will instruct that spare part to be introduced, set up, next production works fine. So these kinds of sensors are really enabling that kind of automation of things that we used to sense with our hands.
Great. So, Keith, people have been talking about predictive maintenance for a while. Are people actually using it at the moment, and to what level?
People have used predictive maintenance for a very, very long time, Trevor. Not so much in SMT, but in semi. And I'm completely in agreement with Michael, and I know that this gentleman on my right will be as well. The more information that you get from your machines, the more you can put it into a central, let's call it, control area, the more intelligence you have in your system.
Yeah.
And the ultimate predictive maintenance is you shut the line down at the same time every month, and you do everything that's needed, and the next day you fire it up, and for the following month it runs 24/7 without missing a beat.
Right. Yeah, I mean, there's different levels of predictive maintenance. There's people that are, there's predictive scheduling, as you're saying there, making sure that the maintenance is done when the lines are down and not interrupting the production process. But then there's the other types of predictive maintenance where they're predicting the expected life expectancy of a motor or a belt or something like that.
So, sorry if I can jump in, Harold. That's the information that goes to the central database, and they decide if that motor isn't going to last another month, we're going to change it today. We're not going to predict that it's going to last another 3.5 weeks and change it in 3.5 weeks because we don't want the line downtime. What we want to do is to shut the line once for a day, do everything that's going to go wrong within the next month so that there's no meantime between failures, there's no unplanned failure, there's no unpredicted failure, there's nothing apart from a perfect routine running. So it's a matter of using that information that, this motor is only going to last another 2.5 weeks, probably. So we'll change it at the next downtime, which is in a week.
I would like to add here some learnings. We're always talking about the predictive maintenance, which includes a shutdown of a line. But with the information of things which are not working proper, you can even go for a dynamic change. You even don't stop the line, you change the nozzle, you do something like this, you change the stencil. And this is extending the real downtime to the later time. So dynamic exchanges is also predictive maintenance because you predict the exchange in a time without shutting down. And I think this is a true aspect of predictive maintenance. We know that something is going wrong and will go even worse.
Right.
And then we start the process and to trigger the process.
Okay.
Yeah, you see, I'm going to, much as I hate to do it, I'm going to disagree with Harold. That's not maintenance. That's fixing your production line to keep your yields where they should be. And for me, that's a different animal. And
to keep the nozzle.
No, you change it. If your machine says the vacuum's gone on this nozzle and all these components aren't where they should be, you've got to change it there and then. But that's not what I would look at as maintenance. That's something to improve your yield. Maintenance is to keep the machines running so they don't break down. Yield is to keep your production at a level where you want it to be. And it's a little bit of semantics, but as Harold said, those are the things that go on all the time. Yep. Their SPI machine says we've got insufficient, so you're going to clean the stencil. And that's within the realms of production to keep the yields up.
Right.
I see where you're coming from. Can I sort of just add here? 'Cause I agree with both of you, just so there's no fighting. But Harold has a great point, actually, because if you can perform any maintenance job, I mean, the difference between the two point of views is one that is for kind of consumable items, if a nozzle could be considered consumable, something that is changed through a process of automation, which doesn't disturb the line at all. So Keith's point about yield is true, that's fine, but it is a maintenance job, and it's a routine maintenance job, and it's automated, and it's perfect because it's not impacting the line performance at all. And then what Keith is talking about more with the motor example that I mentioned is a kind of more serious thing where something that should be lasting like 1, 2, 3, 4, 5 years is going to be failing within the next month or two. And, the scenario that Keith painted around that is absolutely perfect, so that you can manage that kind of change of device or component in a time that was already going to be, not added value time of the machine. So therefore, you've not lost any performance in production, and you've not risked that machine breaking down abnormally, which would be a huge disturbance to manufacturing. So you're both right, guys, and that's the good news.
Okay, Michael. For me, predictive maintenance is something that you predict is going to happen within a period of time. If you get feedback from an AOI machine that a nozzle isn't working, that's not predictive, that's fix it now.
Oh, no, I mean, I don't say that the nozzle isn't working, but the software now that is in use, and Harold will probably say something about this, you can start to chart, through analysis of the data, the performance of the nozzle such that you can start to do that replacement before you have a negative impact. So it's exactly the same algorithm. It's simply avoiding, rather than a breakdown, which a motor would represent, but this is a breakdown of quality, or so that would have some impact. So it's the same principle, but definitely not waiting for the problem to happen. The predictability is the knowledge that the problem could happen very soon and avoid that situation. Harold, is that right?
Good. Well, thank you for that. So I think we'll move on to the next question now. And I'm going to look at the topic of virtual reality, because we are talking about smart factory digitization here. You have virtual reality and you have augmented reality, but virtual reality is still being touted as a strong training tool. But current systems cause dizziness or nausea after 20 minutes. You can only wear these goggles for 20 minutes. Is this likely to change, or is augmented reality the only real alternative? Harold.
So we implemented the tools now from headquarters. We have the customers are using different models. They prefer the Google, they prefer this application, that application. We cannot justify and really decide, so we have to implement the infrastructure that we can handle it. Especially the last 2 years showed us that it's very important to have this kind of tools, because we could not go on site to fix things, and our distributors could not fix the on-site. So yes, it's changing, it's improving. If you see the first level of releases and you see the today's level, it's a totally different story. And I think it's everywhere, and it's very, very useful.
Yeah, okay. Michael, I believe you're firmly in the AR camp from the offerings that you have at Aegis. Am I correct?
Mm-hmm. Oh, yes, absolutely. Augmented reality is nice because it is relatively inexpensive. You are seeing the actual field of view, and you're seeing information come up to guide you what to do next. And, this is not just for training. This is actually for normal operations. So we're recording traceability and actions that are taken. So it's a fully interactive environment. If we were to look at things like mixed reality, which are in fact getting a lot better now. I mean, the technology is moving on hugely. I mean, I saw a demonstration recently where, somebody could just put on one of these headsets, go to a machine, start opening things up, turning things off, dismantling heads and things. And, it's amazing. I felt that I was now empowered myself to be able to go and do that properly without destroying anything. I wonder, though, whether that specific use case goes beyond training, because I remember with operator instructions in the past, you would kind of learn what to do, and pretty soon having to look at the instructions got in the way. And I think even these mixed reality portals, and certainly the VR portals, they're going to get you up to a speed very quickly, and then you just want to get rid of that as a distraction, because you know what to do, you know where things are, you know how things are supposed to be, and you just want to do it. So again, that goes back to the fully interactive nature of AR, where you're less focused on giving people information about what to do, and you're more focused on making sure that that is all executed correctly, so that you're collecting the traceability information.
I think you're right. I think it's used as a troubleshooting tool as well, for absolutely sure. Well, we're running out of time here, so I'm going to very quickly go to my last question, starting with Keith. Very quickly, what more can you each offer manufacturers to hasten or improve their digital transformation? What is the one thing they could do?
It's feedback from sensors, and it's acting on that feedback. And it's really as simple as that. You know, as other people have said here, you know, the machines are getting cleverer. The machines are getting more data coming out of them. Mm-hmm. We just need it all linking together and controlling, and then we'll move step by step to being a lot smarter than we are today.
There you go. Excellent advice.
I think the key is the visualization of all the data, the outcome, and to build up the trust on the decisions.
Right.
I think that is our way.
So visualization of the data, but you also subscribe to the idea of collecting all the data, any that you can, whether you need it now or not, because you might need it tomorrow.
You need it in the background. It's not that you need it now, but you need it for statistical prediction, all these kind of things. You have to have the history that you can predict the future. And you have to prove the decision process. What happened today, how can it happen tomorrow, and how will it happen tomorrow? And I think that's the world of the digital twin perspective.
Great. Okay. Last word to you, Michael.
Okay, I would like to take it back to where we started. We started with this Global Smart Industry Readiness Index, which, you know, was allowing people to assess where they are in terms of being an organization. What I would see as the next step after that is what I call the AIQ assessment. You know, we all talk about the human's IQ, how clever we are, how smart we are. Well, how smart is your factory? How do you know that you're making the most out of the data? Or how do you understand what opportunities are there and that you're taking maximum advantage of them? So we've got a little thing where we go through and, you know, help people to understand what data is available, how that data is used, how it should be contextualized, so put together with many other pieces of information to create facts that can then be used to manage production in real time. So that AIQ assessment is a really, really interesting way of determining how smart you are right now, where you would like to be in the future, and highlight what you can do in order to get there.
That's very sound advice. I think it's a great idea, this global index, and I think it'll certainly be something that will be seeing developed in the future. Anyway, we've run right out of time. They're switching the lights off here, so that's going to be it from Nuremberg for today. I want to thank our guests, Keith Bryant from Keith Bryant Consultancy, Harold Eppinger from Co-Young, and of course Michael Ford from Aegis Corporation. So thank you everybody, thank you for watching. Sorry about some of the time frames today. We're going to try and get everything back on schedule tomorrow, so make sure and tune in tomorrow for some more live streaming from SMTconnect.
Thanks everyone.
Thanks. Bye.
Bye.
Co-Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, we revolutionized the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Co-Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges. With our global network of sales and service centers, we aim to respond quickly to your needs and to deliver the highest level of customer satisfaction.
Electronics are part of our world, expanding by application to open up new opportunities for automotive, healthcare, and many other industries. But today's manufacturing techniques are not sustainable. They are energy hungry and inefficient, expensive and have limited flexibility. The world is asking us to do better. Introducing Pulse Forge tools, a new approach to thermal processes like soldering and curing. Design with more flexibility, manufacture with fewer process steps, reduce energy use, and decarbonize the supply chain. Expand your creativity to new levels. Designers are asking for more. They need to reduce form factors, reduce weight to work on wearables and stretchables, opening new market opportunities for consumers across the world, asking us to do better. If you think sustainability and freedom of design are not possible in electronics manufacturing, think again. Think PulseForge.
At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.